Right, today we are going to look at integration of exponential functions. Integration of exponential functions. Then after integration of exponential functions, we are going to look at integration of trigonometrical functions. But we want to start with integration of exponential functions. Let's say we are given integral of e to the power f of x dx. Then integral of this function, here we differentiate the function that we are given, which is e to the power fx. We differentiate f of x, then we divide by the derivative plus a constant of integration. Right? So we just differentiate the power, then we divide by the derivative. That is how we integrate exponential functions. Let's take, for example, let's say we are given integral of e to the power 5x plus 2 dx. This can be written as e to the power 5x plus 2 all over derivative of 5x plus 2, remember it's 5, plus a constant of integration. Then another example, let's say we are given integral of e to the power 2x times integral of e to the power 2x times e to the power x minus 3 dx. So this can be written as e to the power 2x times e to the power x. We add powers here, which will be e to the power 2x plus x, that's 3x, minus 3 times e to the power 2x dx. Now we integrate each term with respect to x, right? So here we have integral of e to the power 3x, that's e to the power 3x divided by 3. Remember, we differentiate the power and divide by the derivative. Then 3 minus 3 e to the power 2x over derivative of 2x, that's 2, plus c, which is a constant of integration. So whenever we are integrating exponential functions, you differentiate the power, then you divide by the derivative. You differentiate the power, then you divide by the derivative. That's how we integrate exponentials. Now let's look at integration of trigonometric functions. Let's look at integration of trigonometric functions. Integration of trigonometrical integration of trigonometric functions. Right, let's say we want to integrate, that will be given in the formula plate. Let's say we want to integrate sine x, integral of sine x dx is equal to negative cos x plus c. Then number 2, integral of cos x dx is given by sine x plus c. Then number 3, integral of sec squared x is equal to dx is equal to sec squared x dx is equal to tan x plus c. Right, so how do we integrate trigonometric functions? Let's look at an example. Let's say we want to integrate, e.g., number 1, integral of sine 2x plus 1 dx. This is given by. So now, whenever we are integrating trig functions, we differentiate the angle, then we divide by the derivative, right? So in this case, if we differentiate this angle, we get 2. But remember, integrating sine will be negative cos. So in this case, we have negative cos. Our angle will remain unchanged, which is 2x plus 1 divided by the derivative of this one is 2 plus c. So this can be written as negative half cos 2x plus 1 plus c. Don't forget to write the constant of our integration. Right? Another example, integral of 2 cos 4x, integral of example number 2, integral of 2 cos 4x dx. Right? Remember, whenever we are integrating cos, it will be sine. So in this case, we have 2 sine 4x. The angle will remain unchanged. All over derivative of 4x is 4, so we divide by 4 plus a constant of integration. So 2 divided by 4 is 1 over 2 sine 4x plus c. Right? Let's look at another example. Number 3. Example number 3. Integral of cos 3x, integral of cos 3x plus pi over 2 dx. This one is written as, remember, integrating cos is sine. Then integrating cos, that will be sine angle 3x plus pi over 2 divided by the derivative of this angle. Differentiating 3x becomes 3. Differentiating pi over 2 will be 0. So here we have plus c. Now we have 1 over 3 sine 3x plus pi over 2 plus a constant of integration. This is how we integrate trig functions. Now let's look at trig functions with sine squared x and cos squared x. Sine squared x and cos squared x. Integration of trig functions, but now we are looking at sine squared x and cos squared x. Let's say we want to integrate cos squared theta d theta. In this case, we recall the identity for cos, for double angle formula. Cos 2 theta is given by cos squared theta minus sine squared theta, then 2 cos squared theta minus 1, then 1 minus 2 sine squared theta. So whenever we want to integrate cos squared theta, we use this identity. In this case, we can take cos 2 theta is equal to 2 cos squared theta minus 1. Then we make cos squared theta subject of formula. To make cos theta subject of formula, cos squared theta subject of formula, we move 1 to this side. So we have cos 2 theta plus 1 equals to 2 cos squared theta. Then divide by 2 both sides by 2. Here we have cos squared theta is equal to half of cos 2 theta plus 1. So instead of integrating cos squared theta, we substitute with half cos 2 theta plus 1. So in this case, we are going to integrate half of cos 2 theta plus 1. That's what we are going to integrate now. So that will be easy to integrate in this form. Now integrating this, we have half integral of cos 2 theta. Remember, integrating cos theta is sine theta. Now cos 2 theta, we have sine 2 theta over derivative of the angle 2 plus theta plus a constant of integration, which is equal to half into, so half we can multiply this, so that will be sine 2 theta over 2 times 2, that's 4, plus theta over 2 plus a constant of integration. Right? So this is how we integrate sine cos squared theta. Then for sine squared theta now, if you want to integrate sine squared theta d theta, you have to use this identity with this one. So taking cos 2 theta equals to 1 minus 2 sine squared theta, you have to make sine squared theta subject to formula. If you are from cos 2 theta equals to 1 minus 2 sine squared theta, you make sine squared theta subject to formula. So try to attempt this question and compare your answer with the one that I'm going to get after working. So please pause this video and try to attempt sine squared theta d theta. Right, solution for sine squared theta. Let's integrate sine squared theta d theta. Integral of sine squared theta d theta is given by integral of, remember we said we are going to make sine squared theta subject to formula here. Now we have cos 2 theta is equal to 1 minus 2 sine squared theta. Therefore 2 sine squared theta is equal to 1 minus cos 2 theta. Then divide by 2 here, by 2 here. Our sine squared theta is equal to half 1 minus cos 2 theta. Now substituting half 1 minus cos 2 theta d theta. Now we integrate this one, that will be half of integrating 1, that's theta, minus, remember integrating cos is sine 2 theta over 2 plus a constant of integration. You can leave your answer at this stage, or you can write it as theta over 2 minus sine 2 theta over 4, 2 times 2, plus a constant of integration. So this is how you integrate sine squared theta and cos squared theta. So now let's look at the last concept for today. Let's look at last concept. Integration by of the integration of the form integration of the form integral of f prime x over f of x dx. This is what we want to integrate now. Right? If we are given integral of f prime x f of x dx, that will give us ln f of x plus c. So if the numerator is the derivative of the denominator, we just take the logarithm of the denominator only. That's the rule that we want to use now to integrate. Right, example, e.g., let's say we want to integrate 1 over x dx. Remember, 1 is the derivative of x, so this can be written as a logarithm ln of what? Of x plus c. Alright. Then number 2, let's say we want to integrate cot x dx. Cot, it can be written as integral of cot is cos theta over sine theta dx d theta. So in this we are using x, not theta, dx. So since cos is the derivative of sine, cos is the derivative of what? Of sine. Now integral of cot is what? It's ln sine x plus c. Let's look at another example. Let's look at another example. Number 3, integral of 5x squared divided by 1 plus 3x squared dx. Remember, we want the derivative of the denominator on the numerator, but 5x squared is not the derivative. Therefore, we can rewrite this as integral of, we can take out 5 here. Remember, derivative of 1 plus 3x squared is 6x. So here we want 6x over 1 plus 3x squared. But if we put if we multiply by a 6 here, we are going to divide the denominator by 6 again. So we can divide by 6 here, which means here we have 5 over 6, here we have 6. So that 6 and 6 will cancel each other. Now that the numerator is the derivative of the denominator, we can say it's 5 over 6 ln 1 plus 3x squared plus a constant of integration. Just make the numerator to be the derivative of the denominator, then you integrate. Another example. Let's say we are given integral of 3x over x squared plus 5, integral of 3x over x squared plus 5 dx. Right, we can rewrite this as 3. Here we have x. Remember, we want the derivative to be 2x, but we have x squared plus 5 here. So we multiply here by 2, then we divide by 2. Now we have 3 over 2 ln x squared plus 5 plus a constant of integration. Right, so this is how we integrate this form. If the numerator is the derivative of the denominator, we just take logarithm of that number. So in these situations, make sure you make the numerator the derivative. You remove 5 here, then you put what is going to be on the numerator. But if you multiply the numerator by 6, remember you are going to divide again by 6, right? So this is how we integrate. So today we looked at integration of exponential functions, we looked at integration of trigonometric functions, and we looked at integration of this form. Now I just want you to go to your textbooks and go through this work. Try to work as many examples as you can, right? In our next lesson, we are going to look at integration of partial fractions, integration by parts, and integration by substitution, right? Have a good day and have a wonderful working day.